And we are live on the Voice of the Cape Facebook and YouTube channel for today's edition of the Matric Revision session. The subject we're covering is physics, and it's related to acid and bases in chemistry, paper 2. So, in preparation for the exams, my guest today is Muntasir Kadri from In Tune Tutoring. We do apologize for the delays, but we are here. Better late than never. Alhamdulillah. Assalamu alaikum, Muntasir.
Walaikum salam. How are you doing today?
I'm very well, Alhamdulillah. I know we've been delayed, so I won't keep up the lesson too long. I'll now hand over to you to proceed, inshallah.
Okay, shukran. Okay, students. So today we will be looking at acids and bases within the chemistry section of your physics module. And this is usually what you will encounter in paper 2. So this just requires you to have an understanding, first of all, of what an acid and a base is. As we know, there's two different types of definitions for acids and bases, one of them being the Bronsted-Lowry definition. Okay. But in general, we know that an acid is basically something that has the ability to donate protons in the form of either H plus ions or H3O plus ions, also known as hydronium ions. And then bases are those things which are able to donate hydroxyls or OH minus ions, right? So the one will increase the negative ions in a solution, and the other will increase the positive ions in a solution. This determines whether something becomes more acidic or more basic. Now, if we look at example 1, the question states that ethanoic acid, CH3COOH, is an ingredient of household vinegar. And they ask, is ethanoic acid a weak acid or a strong acid? So, first we need to understand what the difference between a weak and a strong acid is. A weak acid is something which only deionizes partially in solution, so it's not a complete ionization of the acid, but a strong acid is something that dissociates completely in solution. Okay, in this case, ethanoic acid, which is vinegar, this is a weak acid. And the reason for that is because it only dissociates partially, does not completely dissociate. Right? And that is our answer for 7.1.1. So that's just where you need to understand definitions and be able to identify which acids are weak and which acids are strong. In fact, you can get a table online about strong and weak acids, and then you'll be able to immediately recognize what's a weak acid and what's a strong acid. 7.1.2. An ethanoic acid solution has a pH of 3.85 at 25 degrees Celsius. Calculate the concentration of the hydronium ions in solution. So this is a fairly simple problem. So if we take a look at 7.1.2, I'll just grab this here and we'll add it to our cut. Oh, wait, let me just delete this, not on this page. Let me open up a new document. Let me go here. Here we go. Okay. And we'll grab this. And we add it to this page. Now, let's take a look at this. Okay. So, first thing we need to know is what is the equation to calculate the pH? Well, that is simply pH is equal to the negative log of either your hydronium ions, or it could be that pH is equal to the negative log of our H plus ions. These are the two ways to solve for pH. Okay, there is another one which is POH. I'm sure you remember that pH plus POH is equal to 14. Right? So calculate the concentration of the hydronium ion. So we have the pH. So this is just a simple matter of saying at 3.85 is equal to the minus log of H3O plus. Right? That's all it is. And then this is where you need to understand logarithms. Just where is my calculator? Because I can't solve this without it. Here we go. Okay. So how do we get around this? Well, we can either use lens, or you can remember the rules with regards to exponents and how you get from a log to an exponent. Okay. So we'll just quickly take a look at that. I'll just go to the memo for this. Let me just draw it out. And you can take a quick look, see here. Right. So we end up with an answer of 1.41 times 10 to the minus 4. And this is how we go about it. We end up getting 10 to the power of negative 3.85. Now remember, this is to the base 10. So how did they get that? Well, we'll go back here and we'll take a look. So remember, this is to the base 10, right? And then for logs, if you remember, we can say, let's say log A, B, log to the base A, B is equal to, let's say, C. And how would we write this in exponential form? Well, the B stays here, the base becomes the value over here, and this C goes to the power. And basically, we're going to use this type of conversion to solve for this over here. So we know we got the base 10, so we can write 10 over here. Okay. First, let me first show you this. First, we divide by negative, so we're going to get negative 3.85 is equal to is equal to log. Remember, if they give you no base value by the log, it's always 10. Right? To the base 10, H3O plus. And now we just take to the base 10 minus 3.85 is equal to H3O plus. And if we pop that in our calculator, we'll get the same answer as this over here, which is 1.41 times 10 to the minus 4 moles per decimeters cubed. Easy as that. Okay. Next question. 7.1.3. So here they go ahead and they tell us that sodium ethanoate forms when ethanoic acid reacts with sodium hydroxide. Will the pH of a sodium ethanoate solution be greater than 7, less than 7, or equal to 7? Well, let's take a look at this concept. So if we grab this over here, I'll just grab this, I'll add it to a new page. So this is basically what our reaction is going to look like. So we've got ethanoic acid, which is CH3COOH. We're going to react that with a base, which is sodium hydroxide. So we got a weak acid reacting with a strong base. This is going to give us CH3COONA. Right, this is the salt that forms, and we get water. Remember, whenever you react an acid and a base, you always get a salt and water. Okay, so this is what we get. So is this going to, will the pH of the sodium ethanoate solution be greater than 7, less than 7, or equal to 7? Well, it's going to be greater than 7. Right? Because if we think about what's happening here is, yes, this donates its hydrogen, but it only has one hydrogen available, donates it to the sodium hydroxide, right? And this hydroxyl takes it over, and we end up with H2O. Okay, so if we had to look at the ionic form, we would see that we'd actually have OHs being given off. So here we have CH3COO minus plus our sodium plus. So we're going to get up this hydroxyl over here, right? Oh, sorry, doing this incorrectly. My apologies. Basically, in ionic form, we're going to end up with this over here. Okay, the CH. We ignore the spectator ions, which is sodium. And this hydrogen actually just keeps filling it up with OH minuses, right? So essentially, we're just going to be increasing the pH, right? So we're going to have a pH of greater than 7. And we'll see that there in the memo as well. If we take a look here, greater. And there we can see that this, if we look at the solution, right? They say, explain the answer to question 7.1.3 with aid of a balanced chemical equation. Well, if we take a look at this problem, you're going to see this. right? So basically, this is the first reaction that takes place, right? And then we end up with a solution of this over here, right? Now they're asking about the pH of this solution. So if we think about it, if we have the CH, oops, let me use a different color because that's a bit too yellow. Let's go CH3COO minus is reacting with this H2O. Essentially, this is going to build up more OH minus ions, and we're going to get CH3COOH. Right? So as we're building up these hydroxyl ions, we are increasing the basicity of the solution at the product point of the chemical reaction. And that's essentially what they are telling us here as well in the memo, if we take a look. Right? And that's what's happening over there. And the same thing happens here. So it's a reversible reaction. So they say due to the formation of the hydroxide, the solution is basic. And that's basically what we said. Excuse the pun. Now let's go back here. 7.2. Okay. Household vinegar contains 4.52% ethanoic acid, CH3COOH by volume. A 1.2 gram impure sample of calcium carbonate is added to 25 centimeters cubed of household vinegar. On completion of the reaction, the excess ethanoic acid in the household vinegar is neutralized by 14.5 centimeters cubed of sodium hydroxide solution of concentration 1 mole per decimeter cubed. The balanced equation for the reaction is CH3COOH plus sodium hydroxide reacts to give us sodium acetate or sodium ethanoate plus water. 7.2.1. Calculate the number of moles of the unreacted ethanoic acid. Okay. So this looks a little bit complex because there's quite a bit of information given to us. So we need to be a little careful. We need to highlight some important things. So let's just copy this. We'll add it to a new page. Get up here. So this is quite a tricky one. And let's take a look. So what do they tell us? Let me get my highlighter up. They tell us that we have, oh, no, there we go. Okay. Here we go. All right. So first of all, contains 4.52% ethanoic acid by volume. Okay, so they tell us that, 4.52%. Our sample of calcium carbonate is 1.2 grams and it's impure. Right, so that means that it's not just calcium carbonate that's in here, only about a certain percentage of this is calcium carbonate, is added to 25 centimeters cubed of household vinegar. Well, if household vinegar is only 4.52% by volume, then we don't actually have 25 centimeters cubed of vinegar, do we? No. So if we think about it, this means that we actually have 25 centimeters cubed times by 4.52%. And this means that by volume, we only have, second function percent, 1.13 centimeters cubed of vinegar. And the rest is something else that's diluted, probably water. Okay. On completion of the reaction, the excess ethanoic acid in the household vinegar is neutralized by 14.5 centimeters cube of sodium hydroxide. Okay, so what we do know is that we have two reactions, right? We have one reaction where calcium carbonate is reacting with the vinegar. And this is going to give us calcium hydroxide. Let me just say calcium. Let me just double check. Calcium carbonate, CS3C. It's a metal carbonate and an acid. So we always get CO2 and water. And then we get a salt. And the salt in this case is going to be calcium ethanoate. So it's going to be CH3COONA. But we know that not all of this vinegar is reacting with the calcium carbonate because it's impure. So there's some that's left over. And then we get a second reaction, which is this one over here, where the acetate is reacting with the sodium hydroxide to give us CH3COONA plus H2O. Okay, now calculate the number of moles of the unreacted ethanoic acid. So we're going to have to work backwards from this equation over here. Okay. So on completion of the reaction, the excess ethanoic is neutralized by 14.5 centimeters cube of sodium hydroxide. So we know that the NaOH, the volume that we used to react it, is 14.5 centimeters cubed. That was to neutralize the rest, right? And it had a concentration of 1 mole per decimeters cubed. Well, guess what we can do here? We can now figure out the number of moles of sodium hydroxide that was required to neutralize the excess acetic acid. That's just from the information they gave us here. So I'll remove this equation. It may not be necessary at the current moment. So now we can go ahead and we can be like, okay, if that's the case, that means N is equal to, well, C is equal to N over V. So N is equal to C. C is equal to N times V. So N is equal to C over V, concentration over volume. We need to convert this 40.5 centimeters cubed to decimeters cubed, because that's what we have here in the concentration. So we convert this quickly. And we know that 1 centimeter cubed is the same as a milliliter. So that means we just divide this by 1,000, because 1 decimeter cubed is a liter. And that gives us a value of 0.0145 decimeters cubed. So we go ahead and we say, well, if we're going to take 1 and we're going to divide it by 0.0145, you're going to get a value of 68.97 mole. Hold on, let me just check if I did this right. This seems very big. C is equal to N, C equals equal to N over V. Yes. N is equal to C times V. My apologies. I thought something was weird here. Sorry. N is equal to C times V. There we go. That makes more sense. And then we just basically going to get 1 times by 0.0145. And therefore we get an answer of 0.0145 mole of sodium hydroxide that reacted with the acetate. So if we look at this equation, we can see that the equation is balanced. In fact, the ratios are 1:1:1:1. Right? So we have a very standard ratio. So this actually makes it very easy for us to determine the number of moles. We look at the ratios. Well, if we need 1 part, you can think of this as ingredients. If we need 1 part of sodium hydroxide reacting with 1 part of CH3COOH, then we just need a ratio of 1:1. So that means we also have 0.0145 mole of acetic acid that reacted with this. Right? And this would be our answer. And we can check the memo. Let's see here. And there we go. 0.0145 mole. And because the ratio is 1:1, guess what? We can go ahead and put that in there as well. As easy as that. Okay. Next part of the problem. 7.2.2. Calcium carbonate reacts with ethanoic acid according to the following balanced equation. And there we go. They give us the balanced equation, and we actually did the correct thing, right? And they say calculate the percentage of calcium carbonate in the impure sample if 1 centimeter cubed of household vinegar has a mass of 1 gram. Okay. So here's the tricky business going on again. So we know that, and I'll just write this here on the side so we don't lose it. This is 0.0145 mole. Right? This was the excess. Can I remove this? Okay, with the following balanced equation, calculate the percentage of calcium carbonate in the impure sample if 1 centimeter cubed of household vinegar has a mass of 1 gram. So here we've got we will still worked it out from this percentage over here to find out that 25 centimeter cubed of household vinegar actually only contains 1.13 centimeters cubed of vinegar. Now we can take this value and use this ratio of 1 gram to 1 centimeter to solve for how many grams of vinegar was used. So we can just go here and we can say, well, this is going to be equal to, and we can just say uh, 1.1 centimeter cubed to 1 gram, 1.1. Right. Let me just check here. So it's it's, do this. It's 1 centimeter cubed is to 1 gram. 1.13 centimeter cubed is to x grams. So we're going to get basically x is to 1.13. So this means that we actually end up with a value. Let's just see if this is correct. It's used to 1 gram. That's right. Hold on. I don't think I did the correct thing here. Just double checking. Is to how many grams? That's right. We cross multiply. I think I made a little bit of an error here. So x is 1.13. Let me just check something again. So it's 1 centimeter cubed is equal to 1 gram. That is correct. And then 1.1. Yeah, that's right. So this is 1.13 grams. There we go. Right, so we have 1.13 grams of vinegar. Okay. Now, let's see what the next part is. So this is, of course, a very tricky problem. Let's see. Calculate the percentage calcium carbonate in the impure sample. Okay. So if we go back here, this is what was left over. So we need to work out the number of moles of 1.13 grams of vinegar, right? So this is CH3COOH. Remember, always working moles. So now we can go, well, N is equal to mass over molar mass. So we know the mass is 1.13 grams. The molar mass of calcium carbonate is going to be, well, carbon is 12. We've got 2 carbons, so that's 24. Oxygen is 16. We've got 2, so that's 32. And we've got 4 hydrogen, so that's 4. So we know the molar mass is 60. This is 60 grams per mole. We then say 1.13 divided by 60, and that's going to give us a value of 0.019 mole. So this is the total that we had, and this was the unreacted, right? After this is the So this value that we have here was the amount that reacted with um, the sodium hydroxide, right, which was the unreacted amount. So we just take this value and we subtract it from this, and then we know what actually reacted with the calcium carbonate. So now I can go, well, and I'll just say reacted with CaCO3 is equal to the N. So our total minus our N, and we'll call this N total, that reacted with NaOH. Right? And this is just going to equal 0.019 mole. Oh, sorry, my apologies. This is going to equal 0.019 mole subtracted from 0.0145 mole. Okay. And we're just going to get an answer of, let me go 0.019 minus 0.0 145. And that gives me a value of 4,5 times 10 to the minus 3 mole. Right? So this is the amount that reacted with the calcium carbonate. Okay. So now what do we have? Well, we have this number of moles. So now we can work out the number of moles of calcium carbonate that reacted with the acetic acid. And we can see the ratio is 2:1. Well, so we can go ahead and use the ratios to solve for the number of moles of calcium carbonate. So we know that it's going to be 1:2. On the 2 side, we have 4 point, which is calcium carbonate, we have 4 point, the acetate, we have 4.5 times 10 to the minus 3. Over here is the unknown x. We cross multiply. So we're going to get 2x is equal to 4.5 times 10 to the minus 3. So half of this. So x is equal to, and we can divide that by 2, and that gives us a value of 2.25 times 10 to the minus 3 mole. So this here is the amount of calcium carbonate that reacted. Now let's work out how much this is in grams. Well, now we can just go M is equal to N times the molar mass. And this is going to be 2.25 times 10 to the minus 3. And we're going to multiply it by the molar mass. And we just get our periodic table, see what the molar mass of calcium is. Well, that's going to be 40 atomic units. So we can just say 40 grams per mole. Let me go back here. Oops. Go back here. There we go. Right. So this is 40 plus 12 is 52 plus 16 times 4. Sorry, 16 times 3. It's 100. So here we have a value of 100. So this is just going to be 2.25 times 10 to the minus 1. And I'll just double check that. Oops. 2.25 times 10 to the minus 3 equals that, times that by 100. That's correct. And this is just 0.2, sorry. This is the same as 0.225 grams. So out of 1.2 grams, we only used, there was only 0.225 grams of calcium carbonate that was able to react with the acetate. So now we just need a percentage. Well, that's fairly simple. Let me just move this out of the way. So now we want to work out the percentage of calcium carbonate. And all we do is say 0.225 grams divided by 1.2 grams times 100. And that's going to give us an answer of 18.75%. Right? So quite a bit of work just for 8 marks. Right? So you got to be pretty clever with this. You got to know how to work backwards. You got to kind of analyze the problem correctly. It's not the easiest in the world, but with practice, I promise you get better at this. Okay? Now, let's take a look at the memo. Right? And if we take a look, that's what we get. I get 18.08%. Right? So we are right on the nose. We'll still get this correct. Of course, there was a few I didn't round it up, so I didn't use the full decimal, and that's why it looks the way it does. But if I didn't round up, we would get the exact same answer. Okay. And yeah, there we go. So unfortunately, we don't have time to get to the second example, but it basically follows the same trend. So if you want, you can go ahead and you can download this worksheet from the In Tune website, and you can go ahead and try the second example. And yeah, you can, in conjunction with the video that we just had, you can go ahead and you can try solving it for yourself using the same method. Please do not be daunted by acids and bases. It's just trial and error. What you just have to do is, if you have an idea, jump into it, try it, see if it works, right? And another hint I'll give you: always convert your information to moles, and don't be afraid to use your ratios, and always check that your equations are balanced. Very, very important. Okay. So that is it from me today. I hope this was helpful. I hope you enjoy the rest of it as well. Assalamu alaikum wa rahmatullahi wa barakatuh.
Walaikum salam wa rahmatullahi wa barakatuh to you, Muntasir. Shukran for today's session. And thanks to the viewers for following. Do like and share this link, and also go on to In Tune Tutoring's website for free resources to lessons that have been taught today and before. So from myself, Kanita Kamar, and my guest today, we bid you farewell.